3.3 Increasing and decreasing functions in the first derivative test. Please read the shaded part here. Okay. Now, before we do the test, I want to review some concepts that we've been talking about all along. Number one, if y prime is positive, that implies the curve is rising. And if the curve is rising, then you know that your function y is increasing. If y prime is negative, the curve is falling, and that implies that your function y is decreasing. If y prime is 0, that implies that there is some possible local maximum or minimum, and I'll talk about that more in a second. If y prime does not exist, that implies there's some possible local maximum or minimum. These are also called relative, maximum or minimum. Now for the first one, y prime equals 0. Alright, that implies that you have a possible local maximum or minimum. That doesn't guarantee. And a good example for this is y equals x cubed. If you were to graph y equals x cubed, you can see that at 0, there's not a relative extrema. If you go through the derivative, set it equal to 0, you have x equals 0. So see, it's not a guarantee. You always have to check it. Now, what about y prime does not exist? Well, a good example for that is just your absolute value function. Y prime does not exist here. Y prime does not exist at x equals 0 because the derivative from the left does not equal the derivative from the right. So if you have your derivative and you're testing it, you want to test where the derivative equals 0 and where the derivative does not exist. But you have to test it. Now, to show you how this test works, I'm going to go through an example with you. We're given the function. This is a cubic function. It's a polynomial, y equals x cubed minus 3x squared plus 4. It's smooth and continuous, which means it's differentiable everywhere. But the first thing you'll want to do is to find your derivative. And you set your derivative equal to 0. And you solve. You come up with x equals 0 or 2. These are your critical numbers. I also like to call them candidates. These are your candidates for possible extrema. So they haven't won anything yet. They're just a possibility. Now to test it, we're going to use a sign chart. We've used these before. So on the sign chart, you plot your candidates. Oops, let me go back. And you have to do it in this format. I want the derivative, y prime, labeled here in y. And then you're going to check the intervals into your derivative to see if it's positive or negative. So if you check, say, -1, you're going to get a positive value. If you check 1, you're going to get a negative value. If you check 3, you're going to get a positive value. If y prime is positive, that implies that your function is increasing. If it's negative, your function is decreasing. If it's positive, your function is increasing. And I need you to show me this work. Because we can look at it, you can look at it and see where you have a relative extrema. Because right here, if a function goes from increasing to decreasing, you know there's a max here and there's a min here. So you have a relative max, local max, however you want to call it, at x equals 0, and you have a relative min at x equals 2. Now you probably want to have your calculator handy, so you can pause this and get your calculator just so that you can confirm it graphically, what you have found with calculus. Okay, now here's a couple examples like your homework problems. And this is how I want you to do it. I want you to find your critical numbers of your function, and these are the candidates for possible extrema. State the intervals where the function is increasing or decreasing, and you can do that on a number line. Apply the first derivative test, which means to test your sections for plus or minus. To find the relative extrema, then find the y values for the extrema and confirm on your calculator. So number 1, here we have another polynomial. It's a cubic function, and the derivative would be, the derivative is f prime of x is equal to 3x squared minus 12x. If I set that equal to 0, factor out of 3x, I have x is equal to 0 or 4. These are my candidates. Now, in part B, I'm going to state where the function is increasing or decreasing. And I'm going to do that by drawing a number line, plotting my candidates on the number line. I'll have my derivative up top, and it has to be labeled, and my function below. And then I'm going to check into the derivative and find that it's positive, negative, positive. Let's put our derivative back right here so you can see it. Alright, once I've determined whether the derivative is plus, minus, or plus, which means the function is increasing when the derivative is positive, decreasing when the derivative is negative, increasing when the derivative is positive. So that visually I can see there's a max here and a min here. So I say there's a max at x equals 0 and a min at x equals 4. You don't have to write that out. I'm just doing it for teaching purposes. C. Apply the first derivative test to find the relative extrema. We already did that. And now we have to find the y values for the extrema. To find the y values, you plug it into your original function. And f of 0 would equal 15. So there's a relative max at 0, 15. F of 4 equals negative 17. So there's a relative min at 4, negative 17. Let's confirm this on the calculator. So that's 0, 15. And here's 4, negative 17. So might look something like this. Just a rough sketch. Really easy to graph once you know. Now, derivative and you analyze it. Okay, let's do one more example. Let's look at this one. This is not a polynomial. This is a rational function. Remember that notation means this is the same as 1 over the cube root of x minus 1. So let's go through the steps. Let's find part A. Let's find the candidates for extrema. You won't have to memorize these steps. I'll walk you through it on the first test or quiz. So find your derivative, which is the same as 1 over 3 times x minus 1 to the 2/3, or the cube root of x minus 1 quantity squared. Okay, now where does f prime equal 0? If you look in your numerator, up here, 1 will never equal 0, so there's none. Where does f prime does not exist? Well, that would be in the denominator, and that would be at x equals 1. So that's a possible candidate. So we're going to test it. So in part B, we're going to draw a number line. This is f prime, this is f. Let's rewrite our derivative over here. And our critical number, our candidate, was 1. If I check to the left, since this is the quantity squared, this function's always going to be, the derivative is always going to be positive. So to the left it's 1, and to the right it's 1, which shows that if the derivative is always positive, this function is always increasing. So in part C, I have no extrema. Let's confirm that on the calculator. If you go ahead and put it in your calculator, probably a Zoom 4, a Zoom 6, one or the other. Probably Zoom 4 would be best. Looks something like that. F prime does not exist at x equals 1 because there's a vertical tangent there, and vertical lines do not have a defined slope. Their slope is undefined. And that's about it. Just make sure you go through all these steps, show your number line, be sure that you show this and this, so that we know what you're talking about. Confirm it on your calculator. Get used to looking at the calculus and compare it to the graph, and you'll be fine. That's it. Thank you.